discuss projectile motion part. In an object is projected from rest at an upward angle, its initial velocity can be resolved into components. These two components operate independently of each other. The two components, the vertical component and the horizontal component, are independent of each other with the common variable time. Once the object is projected into the air, there is no other force acting on an object. The only force acting on an object is gravitational force. The direction of this force is always downward. The upward velocity undergoes constant downward acceleration, which will result in rising to the highest point and the falling back to the ground. The vertical component of the velocity moves with constant acceleration. The horizontal motion is constant velocity motion and undergoes no change due to gravity. There is no net force acting the horizontal component. The only force acting in projectile motion is the gravitational force. As a result, there is a variety of the vertical velocity, but the horizontal velocity is constant. The analysis of this motion involves dealing with the two motion independently. Here is a figure which shows projectile motion detail. An object is projected at point A and turn at point B and come back to point C to its starting point. A and C have the same level. At point A, the velocity has component v0 y and v0 x. When a body moves from point A to point B, the vertical component of the velocity pointed upward, and as the sign is positive, the magnitude is gradually decreases because of its opposite to the gravity. At point B, the vertical component of the velocity is zero because it is a turning point between B and C. The direction of the velocity, the direction of the vertical velocity is changed. It's pointed downward. The magnitude increases because of it is the same sign. It is in the same direction to the direction of the gravity. At point C, the vertical component of the velocity is equal to the negative of the initial component of the velocity, the vertical velocity. Since point A and point C are at the same level, when it comes to the horizontal component of the velocity, the horizontal component at any point, at A, at B, and at C, is constant because of there is no need for something in the horizontal direction. As seen in the graph, point A is at origin, and point E is at a distance r from the origin with the same level to point A. The horizontal distance or range is equal to v0 x times t, where t is the time of light, r is horizontal distance, and v0 x is horizontal velocity. Motion in vertical direction. A change in displacement in a vertical direction when an object is projected v0 yt plus half a twice, where T is the time at any point, u naught y the vertical velocity, y is acceleration due to gravity downward, y naught 0 at a point A, y final 0 at a point C. Because of returns to its starting point, point C and point A are the same level, so the change in displacement is 0 because of the initial and the final displacement in the y-axis coincides. Therefore, at any point, the vertical component of the velocity, the displacement change of y is equal to naught yt plus half 80y squared, which is the change in displacement is 0, 0, which is 0 is equal to naught yt minus half gt squared. Then solving this equation gives t is equal to 2 times naught sine theta over g. When it strikes that point, this is the time of light, or the time in air. The time ascending and the time descending are the half of the time of light. Therefore, the total time of light equals 2 times v naught sine theta over g. The horizontal distance or the range r is equal to t times v naught x. Combining 1 and 2 gives 2 times v naught sine theta, again v naught cos theta over g, where v naught cos theta, v naught x is equal to v naught cos theta. So the range of the projectile is 2 times v naught sine theta, v naught cos theta over g. The maximum height at point B. The uniform accelerated motion equation, change of displacement y is equal to v naught y final squared minus v naught y initial squared over tg, where v final y is 0 at point B because of the turning point. Y final at point B is equal to h, y initial at point A 0, change of y is equal to h max. V naught y equal to v naught sine theta, and h max equals final y squared minus initial y squared over 2g. This gives v naught sine theta the power of 2 over 3g. These are the maximum heights. Or h max is equal to v naught sine theta the power of 2 over 3g. Our conclusion is the vertical velocity decreases in way up because opposite to the gravity, and increases for downward because the same direction to the gravity. The time of flight depends on the vertical velocity. The horizontal velocity is constant because of no force acting in the horizontal direction. The maximum horizontal distance happens at 45 degrees, and the object returns to starting point v naught final y equals the negative of v naught initial y. When two balls projected at the same speed with different angles will have the same range and the angle are complementary. Ascending time equals to descending time equals half of the time of flight. Here is detail about the motion of an object projected from at angle of 60 degrees. The yellow is the acceleration, the green one is the resultant velocity. So the vertical velocity changes direction with time, but the horizontal velocity is constant. Here are examples. We are going to calculate the maximum height, the range of the projectile, the time of flight, the displacement, and the velocity at any point. John kicks a ball and the ball does projectile motion with an angle of 53 to the horizontal. The initial velocity is 10 meters per second. and the maximum height it can reach, the horizontal displacement, and the total time required for this motion. Sin 53 equals 0.8 and cos 53 equals 0.6. Maximum height. Given initial y is 10 meters per second, initial y times cos alpha is 10 meters per second times 0.6 is equals 6 meters per second. This is the horizontal component of the velocity at any time is constant. The vertical component of the velocity, the initial vertical component of the velocity unit sine alpha, which is 10 meters per second times 0.8 equals 8 meters per second. This is the initial vertical component of the velocity. The v final is 0, the acceleration 9.8 meters per second square. The maximum height, as we discussed in our previous unit y, the whole square over 2g, which is unit y is 8 meters per second, 8 meters per second whole square, 2 times 9.8 meters per second square, which gives 3.2 meters. Range is equal to 2 times u cos alpha times u sin alpha over g. Substituting the number gives 9.8 meters. And the total time of flight is equal to 2u 2 times initial vertical velocity over g, which is 1.6 second. Here is the path of the ball. Path of the ball. From the figure, calculate the velocity at point B, C, D, and E, and the displacement H1, H2, and H3. The time to reach to these points are 0.2, 0.81, 1.5, and 1.6 seconds. The vertical velocity and the displacement at any point is given by the final y is equal to v naught y minus gt. And the vertical displacement at any time equals v naught yt minus half gt squared. Using this equation, the velocity at p, the time is 0.2, and the initial velocity 8 meters per second. Substituting on the equation gives 6 meters per second in the y. This is the final velocity at point B. The horizontal velocity at point B is 6 meters per second in the x direction because of its constant. So in the component for the velocity at point B, 6 in the I plus 6 in the j, the whole meter per second. The magnitude of this velocity equals under radical 6 squared plus 6 squared meters per second gives 8.5 meters per second. And the direction of the velocity tan theta equals the vertical component of velocity over the horizontal component of velocity, which gives 1, and the tan inverse equals 45 degrees. So the direction of the resultant velocity is 45 degrees from the horizontal. The height at point B. The displacement at point B, which is change of y is equal to v naught yt minus half gt squared. Substituting the number gives 1.2 meters. The velocity at point C, since point C is the turning point, final velocity, the vertical velocity at point C is 0. And the h max we are already calculating 3.2 meters. And the horizontal component of velocity is constant at point C, also 6 meters per second. The velocity and the displacement at point D. The same formula we use. The vertical component of the velocity at point D is minus 6.7 meters per second. The negative sign indicates the object returns or changes its direction. And the horizontal velocity at point D is just constant 6 meters per second. And the component of the velocity at point C equals 6 in the I plus 6.7 in the j meters per second is the magnitude, which is 9 meters per second. And the direction is the tan inverse of 40, 1.11, which equals 48 degrees. The displacement at point D in the same formula, ut minus half gt squared is equal to 0.95 meter. The displacement decreases because count to the downward approach to the starting point. The velocity at point E. Using the same formula, the velocity at point E is minus 8 meters per second. Without calculation, we can estimate the velocity when it comes to its starting point. The vertical velocity is the negative of the initial vertical velocity. The initial velocity was 8 meters per second, and the velocity when it comes to its starting point minus 8 meters per second. So you can find, without calculation, the vertical component of the velocity when it comes back to its starting point. The component of the velocity equals 6I minus 8j meter per second. This is the vector point, and the magnitude of this velocity at point C is equal to 10 meter per second. The direction of the velocity at point A is tan theta, the vertical over the horizontal 1.33, which is tan inverse is 51.1 degrees. You know that the previous it is projected at 53 degrees, also it is at 50 degrees, at 53 degree. The displacement at point is zero. There is no displacement because of it is come to the starting point. Here the video shows at what angle is the object attains the maximum horizontal distance, and the direction of the horizontal and the vertical component of the velocity. You can see how the vertical component of the velocity of its direction is changed, and the horizontal component of the velocity is constant. And the gravity due to the acceleration due to gravity is downward. Stoichar is projected at 90 degree. This also projected at 80 degree from the horizontal. At 65 degrees from the horizontal. 55 degree from the horizontal. 45 degree from the horizontal. This is the maximum distance attained. I started with from the horizontal. Thank you for watching. Please subscribe together next video.